Let's take a look at parallel and perpendicular lines. First, let's talk about what they are. Parallel lines is when you got two lines and they're equal distance apart, no matter where you look at them. So the distance here is the same as the distance over to here. So they never cross, never touch, never meet. They're just always the same distance apart. Perpendicular lines is where you have one line that goes like that, and then you have another line that goes like that, and it forms a sharp corner. Specifically, that's 90 degrees. That's like a intersection of the road, and this is like the sides of the road, left side and the right side. They never meet. Just keep going, same distance apart. So that's parallel and perpendicular. Now we're going to see something about the slope, and we're going to use an example to do this. It says fill in a chart of the missing slopes, and we've got slope of the given line, and slope of the line parallel, and slope of the line perpendicular. Okay, so we're given m is equal to 7. Now parallel lines have the same slope. So this first part here, find the slope of a line parallel to the given line. Well, that's just going to be m is equal to 7, because parallel lines have the same slope. Now perpendicular lines have slopes that are negative reciprocals. So perpendicular lines have slopes that are negative reciprocals. So we're going to start with the given slope. Which in this case was 7. And we're going to write it in fraction form. Well, in this case, we just put 7 over 1. If it's not already in fraction form, you can always put it over 1 to create a fraction. Then we're going to flip it. Top goes bottom, bottom goes to top. That's the reciprocal part. Reciprocal means fraction flipped. And then we'll change its sign. So it goes from positive 1/7 to a negative 1/7. So, for a perpendicular line, the slope is going to be negative 1/7. Now, it's pretty easy once you get used to it. For perpendicular lines, you think of it in fraction form if it isn't already in one. Flip it, change the sign. And that's a slope of a perpendicular line. Let's take a look at this one. Got negative 2/3, and for a parallel, very easy. Parallel lines have the same slope, so this would be negative 2/3. For our perpendicular, we'll start with the slope that we're given, negative 2/3. We'll write it in fraction form. Well, it's already in fraction form, so we're fine. Flip it, so it becomes 3 over negative 2. And then change its sign, so it goes from a negative 3 over 2 to a positive 3 over 2. So the m of this is 3/2. And those will be our answers. Now this next one's an oddball case. We got m is equal to 0. Okay. For a parallel, that's easy. The slope's the same. Perpendicular is not so easy. You can't think of the oddball cases in the same sense. Remember, your two oddball cases are m is equal to 0, which is a horizontal line, and m is undefined, which is a vertical line. Well, let's look at the graph of that. M is equal to 0. That's a horizontal line. If I think of the graph that's perpendicular to it, it would be a vertical line. Again, forms that sharp corner. Well, a vertical line is the form x is equal to a number, and m is undefined. So here, your answer is just m is undefined. Again, you can't go through those steps I did up above. You have to think of it in those terms. Now let's look at the other oddball case. They start out with m is undefined. Parallel is always easy. It's always the same. So m is undefined in it. Now perpendicular. Well, let's think of what that means again. M is undefined means it's a vertical line. Looks like that. Perpendicular means I'm going to have a line going across like this, forming a sharp corner. So that's vertical, and this is horizontal. And the horizontal is, again, y is equal to a number. And when you got a horizontal line, your slope is 0. So m is 0. Excuse me. Okay, let's look at our next one. We'll start a new page. And this builds upon what we've been talking about. It gives us two lines and says determine if the lines are parallel, perpendicular, or neither. So L1 is y equals 7x minus 2, and L2 is y is equal to negative 7x plus 5. Well, these two lines are already in slope-intercept form, so that's perfect. We'll identify our slope. Our slope's whatever's before our x. So here the m is 7, and here it's negative 7. Well, to be parallel, they have to be the same. These aren't the same, are they? Perpendicular. Well, perpendicular means I start with one of the slopes. Doesn't matter which one. Let's say I start with 7 here. I write it in fraction form, flip it, and change its sign. And then you see if that's equal to your other one. Well, it's not equal to our other one, so it's not perpendicular either. Well, if it's not parallel, perpendicular, then it would be neither. Let's take a look at another one of those. Y is equal to 0.2x minus 5, and L2 is y is equal to 1/5 x minus 2. Well, on our first line here, our slope is what's before our x, which is 0.2, and if I were to write that in fraction form, it ends in the tenths place, so this would be 2 over 10, or it would be 1/5. The slope of this, again, the fact that it's in slope-intercept form, the slope is just whatever's before our x, it's 1/5. Well, these are both the same, aren't they? Parallel lines have slopes that are the same, so these are parallel. Let's look at this one. First one is 3x minus 2y minus 2 equal to 0. And next one is 2x plus 3y minus 15 is equal to 0. Well, we have to find out the slope of these so we can determine whether they're parallel, perpendicular, or neither. So easiest way is to solve for y. So here I'm going to take negative 2y to the right side. So we get 3x minus 2 is equal to a positive 2y. You take anything across your equals, your sign changes. We want to get to y by itself, so we'll divide everything by 2. So 3/2 x minus 2 over 2 is equal to 2 over 2y. And those 2's cancel. And we get 3/2 x minus 1. And our slope here is 3/2. Now we'll do the same thing on the other one. We want to get y by itself. So I'll take negative 15 to the right side, take the 2x to the right side. And we get 3y is equal to negative 2x plus 15. Anytime you take anything across equals, sign changes. Try and get to y by itself, so we'll divide everything by 3. There we go. And 3's cancel. And we got y is equal to negative 2/3 x plus 15 divided by 3 is 5. Now again, if you got in slope-intercept form, it's very easy. Your slope is whatever's before your x. So slope is negative 2/3. Well, they're obviously not equal, are they? So they're not parallel. Let's see if they're perpendicular. We'll start with one of the slopes. Doesn't matter which one. Write it in fraction form. It's already in fraction form. Flip it. That's the reciprocal part. So 3/2 becomes 2/3. And then change its sign. So it goes from positive 2/3 to a negative 2/3. And I see this now equals the other slope. So again, if you can start with one of the slopes, go through those steps, and it equals the other one, that means they're perpendicular. Now these next ones are building upon what we've been looking at in the last couple sections. So let me start a new page. Number 8. And given 2, negative 4. And we've got y is equal to 5x minus 1. Find equation line that contains a given point and is parallel to the given line. So it's parallel to this. And find equation line. Well, remember our steps for finding equation line. Our first step is to find m. In this case, parallel and perpendicular is a little bit different. Our first sub-step within that is write the given line in slope-intercept form. Well, this one's easy. It's already in slope-intercept form. Or easier, I should say. Step 2 is to identify our slope. Well, if you have it in slope-intercept form, your slope is whatever number is before your x, which is 5. And then C, parallel lines have slopes that are the same. So, the m we're trying to find is going to be 5. Same as that. Step 2, plug in the given point for x and y, and m from step 1 into y equals mx plus b, and solve for b. Well, this is x and this is y. So put negative 4 in for the y. M from step 1 was 5, so put 5 in for the m. And x we said was 2, and then plus b. And now we want to solve for b. 5 times 2 is 10. Take 10 left side, becomes negative 4 minus 10, which gives us negative 14. Now step 3 is to actually write our answer. Back in step 1 we found m, and in step 2 we found b. So we just plug those in. So we said m was 5, and we said b was negative 14. So our answer is y is equal to 5x minus 14. Now some of these problems may ask you to write it in... Actually, they look like they're all slope-intercept form. So I guess that's our answer. Let's take a look at another one. We've got -1, -2, and it's parallel to (2x minus 7y) equals 21. Step 1 is to find m. Our first sub-step within that is to take the given line and write it in slope-intercept form. So we want to solve for y. Well, the easiest way is probably to take -7y to the right side and 21 to the left side. Anytime you take anything across your equals, your sign changes. So that's 2x minus 21 is equal to 7y. And divide everything by 7. So we've got 2/7 x minus 21 over 7 is equal to 7 over 7y. So y's cancel. Or 7's cancel, sorry. I was thinking of something else when I should have been focusing on this. So 2/7 x minus 3 is equal to y. And that's in slope-intercept form. Then we want to identify its slope. Well, if you have that in slope-intercept form, your slope is whatever's before your x, which is 2/7. And remember, for C, parallel lines have the same slope, so the m we're trying to find will be the same as that right there. So m is 2/7. Okay. Step 2. We want to plug in the given point for x and y. Remember, this is x and this is y. So put -2 in for the y. M from step 1 was 2/7, and x is -1, and then plus b. And then we want to solve for b. 2/7 times -1 gives us -2/7 plus b. Take the -2/7 to the left side and becomes a positive 2/7. And this is a mixed number. So we can take -2 times 7, it gives us -14, plus 2 gives us -12, and our denominator remains 7. And then step 3. Actually write our answer down. So plug in the m from step 1, which was 2/7, and plug in the b from step 2, which is -12/7. And that's our answer. Well, let's take a look at the next problem. I got 3/5, and y is equal to 1/5 x minus 1. Now specifically here it says it's perpendicular to that line. Now same instructions. So our first step is to find m. First substep within that is write the given line in slope-intercept form. So write the given line in slope-intercept form. Means we want to solve for y. So we got y is equal to 1/5 x minus 1. This is already solved for y, so we're fine there. Now we want to identify its slope. If this is in slope-intercept form, then your slope is going to be the number that's before your x, which is 1/5. And for C, perpendicular lines have slopes that are negative reciprocals. So we'll start with a slope from B. So start with slope from B. and you've seen these already, but I'll write the steps out again. Then we'll write it in fraction form. Well, this one's already a fraction, so we're fine. Flip it. That's the reciprocal part. Top goes to bottom, bottom goes to top. And then change its sign. So, our slope, our m, is going to be -5/1 or -5. Well, step 2 is still the same. Plug in the given point. For x and y. And m from step 1 into y equals mx plus b, and solve for b. Okay. Now I think the point was 3, 5. So this is our x and this is our y. So x is 3 and y is 5. So we'll put 5 in for the y. M we just said was -5 and x is 3. Then plus b. And we want to solve for b. -5 times 3 is -15. Take -15 on the left side, becomes a +15. And we get b is equal to 20. And we can't forget to actually write our answer. That's step 3. That's where you take the slope you found in step 1 and b you found in step 2 and put it into your answer. So y is equal to mx plus b. And we said m was -5 and b was 20. So our answer is y is equal to -5x plus 20. Now let me start a new page. And let's look at our next problem. So pass this through 0, 0, and it's perpendicular to 8x minus 12y is equal to 5. Okay. Step 1. Find m. Then the first sub-step within that is to write the given line in slope-intercept form. So we want to solve for y. I'll take the -12y to the right side and take the 5 to the left. There we go. So we got 8x minus 5 is equal to 12y. And divide everything by 12. So we got 8 divided by 12, -5 divided by 12, and 12 divided by 12. And then those 12s cancel. Now these are both divisible by 4, so that gives us 2/3 x minus 5/12 equals y. And we just solve for y. That's in slope-intercept form. Okay. Next sub-step is to identify its slope. Your slope, if it's in slope-intercept form, is whatever number is for your x, which is 2/3. Now our perpendicular lines have slopes that are negative reciprocals. So we'll start with the slope from b, which is 2/3. We're going to write it in fraction form. It's already in fraction form, so we're fine. Flip it, take the reciprocal. That's 2/3 becomes 3/2. And then change its sign, so it becomes a -3/2. So m is m is equal to -3/2. That'll become pretty easy after a while. You won't have to write all these steps down. You see the fraction, you flip it, change the sign. Step 2. Plug in the given point, They actually give us y-intercept here, but I'm going to pretend I don't see it. Plug in a given point for x and y. So put 0 in for y. M we said was -3/2, and x is 0, and then plus b. -3/2 times 0 is 0, and we just end up with b is equal to 0. Step 3, write our answer down. Well, from step 1 we said that m is -3/2, and from step 2 we said b is 0. So the 0 drops away at the end, and our answer is y is equal to -3/2 x. One more problem. We got -4, 2, and 5x minus 2y is equal to 3. Okay, first step is to find m. Well, again, remember we write the given line in slope-intercept form. So we're going to take our 5x minus 2y equals 3 and solve for y. So I'll take -2y to the right side. I'll take 3 to the left. Anytime you take anything across your equals, your sign changes. So that becomes 5x minus 3 is equal to 2y. Want to get to y by itself, so we're going to divide everything by 2. So divide the 5 by 2, the -3 divided by 2, and the 2 by 2. Those cancel. And we get 5/2 x minus 3/2 equals y. Now we want to identify our slope. Again, if it's in slope-intercept form, our slope is the number as before, our x, which is 5/2. And perpendicular lines, I didn't write it down, but this is perpendicular to that. Perpendicular lines have slopes that are negative reciprocals. So we start with our slope from b, write it in fraction form. It's already in fraction form. Flip it, that's the reciprocal part. 5/2 becomes 2/5, and then change its sign. So we get -2/5. So m is equal to -2/5. Okay, step 2. Plug in the given point for x and y. That's x and that's y. So put 2 in for the y. M from step 1 we said was -2/5, and x is -4, and then plus b. And then we want to solve for b. -2 times -4 is 8, so we've got 8/5 plus b. Take the 8/5 over the other side. And this is a mixed number rule. We take the number to the side here, the 2, multiply it times the denominator. 2 times 5 is 10, and then we add the -8. So that gives us 2, and then our denominator stays 5. So again, 2 times 5 is 10, and then you add -8, and that gives you a positive 2. Step 3. Can't actually forget to write our answer down. M from step 1 we said was -2/5, and b from step 2 was a positive 2/5. And that's our answer. And that's actually the last problem too, so